In this tutorial, we're going to be looking at using multispectral imagery. Again, start off in the Jebel Samhan area, and we'll load in the vector files for Jebel Samhan extent. Now we're going to load in raster data. Now you can click on the Add Raster Layer shortcut button and navigate down to your data directory. So here, data, Jebel Samhan, and we'll load in Landsat enhanced thematic mapper data. So click on the .img file and it loads our image file. Again, let's get our layering orders sorted out so we can have our boundary at the top. So there we are. We have our Landsat satellite image that looks phenomenally blue, and we know that's not how it should look. So if we go into the attributes here by double clicking, okay, you see here that we have a variety of different tabs that allow us to change and look at the data, to look at the histograms associated with the data, which is now just calculating. Here we are, so a variety of different bands with different histogram statistics. So let's go all the way back to where we were previously on the style. We can change the bands which we set to the red, green and blue. Now Landsat, as a satellite platform, has 7 bands. Well, in fact that's not quite right, but for the purposes of this presentation that will do. Band 1 is blue, band 2 is green, band 3 is red, band 4, 5 and 7 are all in the near and shortwave infrared, so that's beyond what we can see with our eyes, so outside of the visible component of the electromagnetic spectrum, and band 6 is focused on the thermal component of the electromagnetic spectrum. And so essentially we can tell, the imaging part of the software which bands we want to focus on the red, green and blue. So here, for example, we will set band 4, which is the near infrared, to red, band 3, which is the red band, to green, and band 2, which is the green band, to blue. And this will produce what is referred to as a false color composite. And what we'd like to do is to do some contrast enhancement, so we want to stretch that to the minimum and maximum and clip it, and we can click on apply and OK, and we see that we get a what would be a quite close representation to would be the real colours in the scene. Even though this is a false colour composite, the way that the images are structured is quite close to what would be a red, green, blue. Now, the reason why I put the near infrared on the red gun is so we can detect the vegetation, because in the near infrared you're seeing much greater reflectance from vegetation. And so here we're seeing what's the crop trial area, or an irrigated area. We're seeing much higher reflectance here, and that's indicative of vegetation. So let's zoom all the way back out again, and we can see how clearly that stands out just by looking at this area here. Okay, so if we go back through, we can change the bands again. So if we look at red band onto the red gun, the green band onto the green gun, and the blue band onto the blue gun, with the same stretch and clip to minimum maximum, we'll get what is referred to as a true colour composite. So this is what we should be seeing with our eyes when we're down there. And equally we can see that the vegetation of the agricultural element here is still showing up quite strongly. So if we look through, here is Jebel Samhan, and we pan around this landscape, we can see the wadi systems, we can see the edge of the escarpment. It's all showing up rather clearly. We can see this cloud pattern here, and if we zoom in a little bit more, we can see, getting to the blockiness of the resolution, because Landsat is a 30-meter pixel resolution, so we see there the cloud and the shadow underneath the cloud. Fantastic. So let's have a look at what we can do with some of the other bands. Now let's use the shortwave of two of the shortwave bands, so band 7, band 5 and band 3. So 2 shortwave bands and the red band. And we'll apply this. So what can we see? Well, for a start, we can see that we've got a change in this cloud. It's got greater reflectance in the blue gun, and that blue gun has been attached to a red, so we're seeing a difference in the cloud. We're also seeing the ability to make some more subtle discriminations of what's going on in this landscape. Now we know that this is pretty much exposed rock, and what we're seeing by using a 753 combination is the ability to discriminate more in geology, and this is one of the major benefits of using multispectral sensors that are configured particularly outside the visual components of the electromagnetic spectrum, because different materials reflect electromagnetic energy in different ways, and what you can produce is a spectral signature which you can use to identify specific material types here. Specific material types. And here we're looking at different reflectance in the geology, so the soil and the rocks, which are producing different colours which we can identify. So here we're seeing the Wadi silts are reflecting very highly, and that's got a lot to do with the particle size of the wadis themselves, because the particle size impacts upon different reflectance rates. But also we're seeing the different chemistry of the rocks coming through. So when we have the escarpment edge here, we're looking at the different rock profiles in the geology which are exposed in different ways, and they're reflecting their differences, essentially. You can also see the striations down here, so we can pick up quite a lot of geological information directly from the Landsat